If I were to do the arctangent of negative 4/3, now 4/3 or negative 4/3 is not a ratio that comes up with a special angle. So here, I'm going to and since there's no other function stuff going on, I'm going to have to come up with an answer for this. I use my calculator. So I get approximately negative 0.9273. The problem is that's not a positive number. I'm looking for the smallest positive value of x that would cause this to happen. So I have to think about, okay, well, that's the answer I'm getting from the arctangent function. I got to figure where else can tangent be negative. Well, first of all, I know that it has a reference angle of 0.9273. And that's the important thing here, is to find out what the reference angle is. Now I'm going to look for the smallest positive number, x. So I start at my x-axis and I start moving in that counterclockwise direction. When I'm in quadrant 1, tangents are positive. So I'm not going to be in quadrant 1. When I get to quadrant 2 is the first time that I get an angle that could have a negative 4/3 as a tangent value and be a positive value for x. It's going to have the same reference angle, that 0.9273. So x is going to be pi minus that alpha, or pi minus 0.9273. And that's approximately 2.2143. Now, as I do those calculations, I always use all the numbers that are involved and then round off that final result. I only write 4 of them for the sake of, just, saving my typing fingers and writing hand, a little bit. But keep that in mind. I'll probably mention every time I get to a situation like that. I'm going to use the calculator, all the values of the calculator. So even though it says 0.9273, I took pi on my calculator and subtracted the answer I got when I did the arctangent of negative 4/3, or when I did the absolute value of that. So that's the answer there. The cosecant of x being negative 3/2. Now, technically there are arccosecant, arcsecants, and arccotangents. We don't make use of them because it gets even more complicated when you start discussing ranges and things like that. So we don't bother with those. If I'm given that the cosecant of x equals a negative 3/2, that means that the sine of x has to be a negative 2/3. That's just, we're doing the relationship between cosecant and sine. So looking for an angle whose sine is negative 2/3. Now, negative 2/3 is not one of the ratios I get when I take a sine of a special angle. So I'm going to have to use the calculator. And when I do, I'm going to take a step out of, this, and realize that if I do arc sine of this, I may not get what the reference angle is, but an angle closely related to it. So I'm going to take that absolute value just to be sure, and I want to get the reference angle first. And that reference angle is approximately 0.7297. So I want to think, okay, well, I want a positive angle that's going to give me a negative value for sine. Well, the first time if I'm moving in that counterclockwise direction, the first time that I get an angle like that is when I enter into the third quadrant. Because quadrant 1 and quadrant 2, sine is positive. So I have to make sure. So if I'm going that positive direction, the first time I get an angle that's going to give me a negative value for sine is when I enter into quadrant 3. So I want a quadrant 3 angle that has that as a reference angle. So that means I'm going to go alpha more than pi. So I'm going to take pi and add that 0.7297, and I get approximately 3.8713. Now again, because it was only asking for the smallest positive number x, I only get one answer for each one of these. Each one of these equations actually has an infinite number of answers. So, keep in mind that, if it just says solve the equation, well then that's a different story, because I might have multiple answers or an infinite number of answers depending on any restrictions they give me for possible solutions. And we're going to see more of that as we go through other examples in a moment.